Hello and welcome. We're going to today talk about our project. We started from being overexcited about this project, about building a mechanical machine. It was our first one. However, we went from being overexcited to being mad, to going to giving up another project, to even going to wasting 4 hours on a chip that didn't work. You know the pain? So we have returned back from the intro. Hello back. So we are gonna start saying our aim in our project. We started to think about something that would help us in the accuracy of humans, because if you are talking about moving objects, it was proven in a lot of researches that the accuracy of moving this object isn't that high. It's actually really low. It was proved in many researches. So we had to think about something that would help us in that problem. So we started about thinking about a robotic arm that would hold something heavy. So I know this is a prototype, it's not one, so do not judge us please. But think about it in a big scale. It can move objects in similar lines. It can move the big pods that hold molten iron. It can be even used somehow in medical fields. I'm not sure about it, but of course there will be a way. Put in your mind that we are engineering students who are actually M18s who do not know anything about the mechanical engineering behind this project. Even though we didn't take anything about mechanics, we were able to build this contraption that is working. Do you imagine something that we had a lot of time spent on it? It works! It works! So, also, because we are also students and we didn't have that high of a budget, we had like about 500 LE, 100 LE from every student, pounds, 9 pounds in every student, and we didn't have any more. And you can see that in our prototype, I guess. See the amazing wood? Yeah, there's a lot of quality in it. Now we're gonna move to explanation of this contraption with my friends.
Okay, now we're going to talk about the hardware that the mechanical robotic arm is made of. Of course, as you can see, the quality is not that good, and I'm being respectful to this project. But anyway, we used plywood for this robotic arm. As you can see here, it's really light and it helps the motors to operate better. Of course, the motors are small; they are not powerful enough to carry heavy objects. So we use this plywood and stepper motors. We got two of them, two types. Two big motors that consists of 4 coils each, and one small stepper motor. Surprisingly, it has 8 coils, but each one has its own mechanics. We're going to get to that later. Anyway, to continue what things you're seeing here. Sadly, we didn't have enough time to think about a good base, so we used CDs. Okay, sorry about that. Anyway, CDs, and they are having as reinforcement some plywood again. The whole mechanism has been glue gunned. Okay, so anyway, but it's I assure you it's enough. This will hold the robotic arm somehow. Anyway. And of course, this is the gripping mechanism that we have. This is to compensate, also make weight reduction in the robot, but as we can see here, the plywood, this has been used here and glued to the plywood over here to hold it in place. As of course, why did we do that? Well, there's a very good reason. This small motor surprisingly has the most torque in all of the big motors, surprisingly. So what we did here was make a small winching mechanism, like a fishing rod. You just winch this this thing over here, this string. You're going to take this string over here, okay? It has been winched and glued to this gear, which I got from a toy, and the motor has been glued to this gear. What this does simply is as follows. I'm going to open the switch for the winch. Okay, so now as we can see here, no, we don't see anything, sorry for that power issue. Anyway, this here now is going to rotate. As it rotates, it pulls the string as a fishing rod mechanism, opens this mechanism for holding anything, for example like a pen, as demonstrated before or after the video, I don't know. Anyway, close on that pen. So now we got ourselves a closing and opening mechanism, which is great. It's really sufficient for a prototype. Anyway, and also here, this is a very nice touch, I think. Now we got ourselves here this gear. It has been, this mechanism is a bit also not that smart, but it does the job. This motor has been welded here, or glued here to this plywood, and by some tiny calculations, we placed this plastic gear, glued it to the other plywood, which is this arm here. So when this motor rotates, you can see it works. So that's a part of prototyping. Of course, in industry it will be totally different. This is only an idea demonstration, and that's it for now. And now for explaining the mechanics of this motor over here. This is a stepper motor. What it does is as follows. A DC motor has only 2 wires. Put it with the battery, clockwise, anti-clockwise. It rotates depending on the poles. You positive, negative with power. For example, it goes clockwise. Negative, positive, it goes anti-clockwise, for example. And here now we got a demonstration of a GIF, if you will, here, that can show you how the stepper motor works. Here you got as follows. This is the stepper motor, as we can see. What it does here, it has 4 coils, okay? So simply, this coil is the first one to have the power connected to it. So this, it acts as a magnet, so it pulls the gear up. The second one, is here. So when it's the second one to get power, so it pulls this whole gear to the side, as we can see over here. Of course, very nice, very nice. Here we go. Sorry for this. Okay, as we can see here, this is the first coil which gets the first power, so it works, pulls the gear up. The second one pulls the gear here. Third, the same story. Fourth, the same story. Okay, now and for the part, and that's all.
The function of the robotic arm is really simple. The main aim of the robotic arm is to move an object from one place to another place. However, in order to implement it, it was really complicated. One of the problem we faced during implementation of the robotic arm was that in the motor rotating. We found the code for rotating the motor in a clockwise direction. However, we couldn't find the code in order to rotate it in the other direction. By trial and error, we discovered that if we reverse this string here, and this string we reverse it also, and this string we reverse it also, and this string we reverse it here, it would work. We did it by using trial and error.
So why is the clock important? Unsuitable clock cycle timing, the result will be unstable rotation, which means the motor will go one step to the right, clockwise I mean, and one step anti-clockwise, which will result in a vibration motion or no motion at all. So we have a code here that we've written. So the small stepper has 8 coils, so it requires low time to rotate a single rotation. So the required time we found on the internet was 1 millisecond, which was represented by the number of 50,000 in our code. Here it is, which was 50,000 counts from the 50 million of the FPGA clock. As for the big stepper, it has 4 coils, so it requires more time for each step. we got ourselves the task of trying different times, and by trial and error sorry, we found out that an acceptable time was 5 million counts, which is there in our code, which is 100 milliseconds.
The pin assignment in the FPGA. These switches are the ones responsible for operating the motors. So this switch enables this motor that rotates the base. And this switch operates the hand, so it lifts it up and down. And these switches close and open the cloth pin. And now we're talking about the connections. This first set of wires is connected to the motor controller for the first motor, and the same with the following two sets of connections. And now we'll talk about how the motor actually works. The motor works by steps, which are each clock cycle. Some of the coils are activated to rotate the motor to one side, and every clock cycle these coils are changed to another coil, which in turn rotates the whole motor. Hello again. So, to conclude what we have said that we have to create the arm. Why did we make the arm? The aim of the project. I'm gonna be explaining why we did it, because it was simply because we wanted to help humans for either to improve the accuracy in moving objects, or just do the tasks that humans cannot be involved because it's way too dangerous for them, or we can easily do it, or we can even do it. That's how we're gonna end our video, and thanks a lot.